Are black holes portals to parallel universes? What if everything we know about black holes is wrong? For decades, we've been told they're cosmic graveyards, places where matter goes to die, where stars collapse into points of infinite density and nothing, not even light, can escape. But what if that's not the whole story? What if black holes aren't endings at all? What if they're doorways, passages to somewhere else, somewhere we can't see, somewhere that exists outside the rules of our universe? The idea sounds like science fiction, but some of the greatest minds in physics have considered it seriously, because at the center of every black hole lies a mystery so profound, so fundamentally unexplainable, that it breaks the laws of physics themselves. And when the laws break down, anything becomes possible. To understand why black holes might be portals, we need to understand what they are, not the simplified version taught in schools. The real thing, the mathematical nightmare that keeps physicists awake at night. A black hole forms when a massive star runs out of fuel. Nuclear fusion stops. The outward pressure that held the star up against its own gravity disappears. And in an instant, the core collapses. Not gradually, catastrophically. The star's mass compresses into a space smaller than a city, then smaller than a mountain, then smaller than a grain of sand, and it keeps collapsing. According to Einstein's equations, there's no force in the universe strong enough to stop it. The collapse continues until all the mass is concentrated at a single point. Zero volume, infinite density, a mathematical impossibility called a singularity. But before you reach the singularity, you encounter something else. The event horizon, the boundary of no return. Cross that line, and you're gone. Not destroyed, not yet, but separated from the rest of the universe forever. Time itself behaves strangely here. To an outside observer, you would appear to freeze at the horizon, your image red-shifted and fading, taking an infinite amount of time to cross. But from your perspective, you'd fall through in seconds, experiencing nothing unusual at first, until you got closer to the center. Here's where it gets disturbing. As you fall, the difference in gravitational pull between your head and your feet becomes extreme. If you're falling feet first, your feet are pulled harder than your head. The tidal forces stretch you. Spaghettification, physicists call it. Your body elongates. Cells tear apart. Atoms separate. You become a stream of particles, spiraling down into the singularity. And then what? No one knows. Because the singularity isn't just a point where density becomes infinite. It's a place where Einstein's equations break down completely. General relativity, the theory that describes gravity, space, and time, stops working. It produces infinities. Nonsense answers. Physics itself fails. When a theory produces infinity, it's a sign that something is missing, that the theory is incomplete, and that's what haunts physicists about black holes. We can describe everything up to the singularity, but at the singularity itself, we're blind. The math doesn't work, reality becomes undefined, and nature doesn't do undefined. So what's really at the center of a black hole? Some physicists think the singularity doesn't exist, that quantum mechanics, the physics of the very small, prevents infinite density, that at some unimaginably tiny scale, something else happens. The matter doesn't collapse to a point, it transforms, tunnels, connects. To what? In 1935, Einstein and his colleague Nathan Rosen discovered something strange in the equations. A solution that described not just a black hole, but a tunnel. A bridge connecting two separate regions of spacetime. They called it an Einstein-Rosen bridge. We call it a wormhole. The math was clear. If black holes could exist, then so could these bridges. Shortcuts through the fabric of the universe. One end could be here, the other end could be on the opposite side of the galaxy, or in another galaxy entirely, or in a completely different universe. There was just one problem. The bridge would collapse instantly, faster than light could travel through it. For a wormhole to stay open, you'd need something exotic. Matter with negative energy, negative mass, something that pushes instead of pulls. And as far as we know, that doesn't exist in nature. But here's the uncomfortable question, are we sure? Quantum mechanics allows for strange things. Virtual particles that pop in and out of existence, Energy fluctuations that violate conservation laws for brief moments. The Casimir effect, where two metal plates in a vacuum experience a force pushing them together, caused by negative energy density between them. It's real, measurable, tiny, but real. Could there be enough negative energy at the center of a black hole to hold a wormhole open? We don't know. We can't look inside. We can't send a probe. Anything that crosses the event horizon is cut off from us forever. We can't receive signals, can't retrieve information. The interior of a black hole is fundamentally unobservable, which means it could be anything. And this is where the speculation gets wild. Because if black holes are wormholes, where do they lead? One possibility is that they connect to white holes, theoretical objects that are the opposite of black holes. Instead of pulling everything in, they push everything out. Nothing can enter a white hole, but everything that falls into a black hole might emerge from a white hole somewhere else. The equations allow for this. White holes are just as valid mathematically as black holes. We've just never seen one. Or have we? Some physicists have suggested that the Big Bang itself might have been a white hole, the sudden appearance of all matter and energy in the universe, erupting from a single point. What if that point was the other end of a black hole? What if our entire universe is the interior of a black hole that formed in another universe? And what if every black hole in our universe is creating new universes of its own? It's called cosmological natural selection. The idea that universes reproduce through black holes. Each black hole spawns a new universe on the other side, with slightly different physical constants. And universes that produce more black holes produce more offspring. Over countless generations, universes evolved to maximize black hole production. It's speculative, unfalsifiable, but it fits the math, and it would explain something puzzling. Why the physical constants in our universe seem fine-tuned for black hole formation. Why stars exist. Why galaxies exist. Why the universe is structured the way it is. Maybe it's not fine-tuning. Maybe it's evolution. But there's another possibility, one that's even more unsettling. The multiverse. Modern physics increasingly suggests that our universe isn't alone. Quantum mechanics implies the existence of parallel universes where every quantum event plays out differently. String theory requires extra dimensions we can't perceive. Inflation theory suggests that our universe is just one bubble in an infinite foam of universes, each with different physical laws. If the multiverse is real, could black holes be the connecting points? Could they be tunnels not just through space, but through the multiverse itself? Could you fall into a black hole here and emerge in a universe where the laws of physics are different, where time runs backwards, where gravity is a billion times stronger, where entire categories of particles exist that don't exist here? There's no way to know, because crossing the event horizon is a one-way trip. You can't come back. You can't send a message. Even if you discovered a parallel universe on the other side, you'd die before reaching it, torn apart by tidal forces, and your information would be lost forever. Or would it? This is the black hole information paradox. One of the biggest unsolved problems in physics. Quantum mechanics says information can't be destroyed, ever. If you know the exact state of every particle in the universe right now, you can theoretically calculate what the state was in the past or will be in the future. Information is conserved. It might get scrambled, hidden, encoded, but it never vanishes. Black holes seem to violate this. When something falls into a black hole, its information disappears beyond the event horizon. And when the black hole eventually evaporates through Hawking radiation, the radiation carries no information about what fell in. The information is lost. Gone from the universe. Erased. This bothers physicists deeply because if black holes can destroy information, then the universe isn't deterministic. The future isn't encoded in the present. Reality becomes fundamentally random, and all of quantum mechanics might be wrong. Stephen Hawking spent decades wrestling with this. Initially, he argued that information was destroyed, that black holes were exceptions to quantum mechanics. But later, he changed his mind. He proposed that information isn't lost. It's encoded on the event horizon itself, on the surface of the black hole, as a hologram. And when the black hole evaporates, that information is released back into the universe, scrambled beyond recognition, but technically preserved. But what if Hawking was wrong? What if the information isn't encoded on the surface? What if it passes through, to wherever the black hole leads? If black holes are wormholes, if they connect to other regions of space-time or other universes entirely, then information isn't destroyed, it's just relocated, moved to a place we can't access. From our perspective, it's lost. But from a cosmic perspective, it still exists, somewhere else. This would solve the paradox, but it raises new questions. If information can pass through black holes, can anything else? Could a sufficiently advanced civilization use black holes as transportation? Could they engineer wormholes, hold them open with exotic matter, travel across the galaxy in seconds, jump between universes? The physics doesn't forbid it. It's insanely difficult, maybe impossible with any technology we can imagine. But the equations don't say no, they say maybe. And in science, maybe is enough to keep asking. But here's the thing. Even if black holes are portals, we might never prove it, because observation is impossible. We can't look inside. We can't send a probe and get data back. Any experiment would be one way, fatal. You could jump into a black hole. Maybe you'd discover a parallel universe. Maybe you'd find nothing but death. Either way, you couldn't tell anyone. This is the fundamental problem. Black holes represent the edge of human knowledge, not because we lack the technology to study them, but because the universe itself forbids us from seeing inside. The event horizon is a one-way barrier. Information flows in, nothing comes out. It's a cosmic censor. Nature hiding its secrets behind an impenetrable veil. And maybe that's intentional. Some physicists have proposed the cosmic censorship hypothesis, the idea that singularities are always hidden inside event horizons, that the universe never allows us to see a naked singularity. Because if we could observe a point where physics breaks down, we might see something we're not meant to see. Something that would shatter our understanding of reality completely. Black holes keep the universe's secrets. They hide the places where the laws fail, where space-time tears, where infinities lurk. And maybe, just maybe, where doorways open to places beyond imagination. Are black holes portals to parallel universes? The honest answer is, we don't know. The math suggests it's possible. General relativity allows for wormholes. Quantum mechanics requires information preservation. The multiverse theory predicts connections between universes. But possibility isn't proof. And we have no proof, no evidence. Just equations, speculation, and questions that might never be answered. Because black holes exist at the boundary between what we can know and what we can only imagine. They are the ultimate mystery, the final frontier of physics, places where space and time break down, where cause and effect blur, where the universe hides its deepest truths behind an unbreakable barrier. We can measure black holes, calculate their mass, observe how they bend light, watch stars orbit around them. But we cannot see inside. We cannot know what waits at the center, whether it's a singularity, a wormhole, a portal, or something stranger still. Something we don't have words for yet. Something that exists outside the boundaries of physics, mathematics, and human comprehension. And maybe we're not supposed to know. Maybe the event horizon is a warning, a line that says, beyond this point, reality becomes undefined. Here be dragons, here be infinities. Here be things that cannot exist in the universe you understand. Black holes are not just objects. They are questions, unanswerable questions, doorways that might lead anywhere or nowhere, tombs for stars, or passages to eternity. We stand at the edge of the event horizon, peering into darkness, wondering what lies beyond. And the darkness does not answer. It only pulls.